10. Let the random variable x represent the weight of male black bears before they begin hibernation. Research has shown that x is approximately normally distributed with a mean of 250 pounds and a standard deviation of 50 pounds. What is the probability that x is greater than 325? Well, this is a standard. We're looking at for one bear, so this is a normal, straightforward z-score problem. My z-score is going to be the weight, or my x, which is 325, minus the mean divided by my standard deviation, which should be 1.5. And then you're going to your z-score chart. We are doing a less than problem. So you would just, oh no, sorry, we're doing a greater than problem. So we would look it up. And then the probability that z is greater than 1.5 is going to be 1 minus the 0.9332 we get. So 0.0668, which should be A. 10. Let the random variable x represent the weight of male black bears before they begin hibernation. Same mean and standard deviation, still normally distributed, but now we're looking for the probability that 3 randomly selected male black bears have a combined weight of less than 700 pounds. So to actually tackle this z-score problem, I need to first find the mean of a bear plus a bear plus a bear. And this isn't just 3x, because if we were doing 3x, it would need to be just one bear we were dealing with, and then for some reason we're tripling it. I don't know what that would be in a bear sense. But we did the sales, or the bullseye store sales stuff where they got triple the amount of points. That's where you're just multiplying by a constant. But here each bear has its own potential weight, and so each time we're treating it as its own separate occurrence. So this is x plus x plus x. So for the mean, it's no big deal. It would be 250 plus 250 plus 250, which is 750. But for the standard deviation, we need to make the old standard deviation a variance by squaring it. And then we have 50 squared plus 50 squared plus 50 squared. And then we need to take the square root because I want to get back to a variance. So my standard deviation should be 86.6. And then it's z-score time. Z equals 700 minus 750. Ugh. All over the standard deviation of just calculated it. How about 86.6, which would be negative 0.58. And then I want the probability that z is less than negative 0.58. Which would be 0.210 or 0.2810, which should be D. The 0.2818 I think comes from an unrounded version, but because I ended up rounding my standard deviation, that's where I ended up with the 0.2810. Use the information for the following 2 questions. The Ranger Scouts are a youth group for boys and girls. Every year as a fundraiser, they sell candy bars, and each Ranger Scout can earn Ranger reward points based on their sales. At the end of the fundraiser, and at the end of the fundraiser, buy prizes with their reward points. During the fundraising period, sales are totaled each week and points are awarded. Let P be the number of reward points earned per week for Scouts, which is approximately normally distributed with a mean of 32 and a standard deviation of 8. 12, what are the mean and standard deviation for 2 weeks of sales for a scout? So we have 2 separate weeks that we are adding together, and I want the combined mean. So I really want the mean of R plus R and the standard deviation of R plus R. Well, the mean of R plus R will be 32 plus 32, which is 64. The standard deviation of R plus R will be 8 squared, so that we have a variance, plus the variance for another week, and then we'll square root to get back. Which would be 11.31. So the mean would be 64, the standard deviation is 11.31. That is letter E. And then last one here, during the final week of fundraising called Double Bonus Deadline Week, the scouts get double the amount of reward points for their sales to promote one last push of selling. What are the mean and standard deviation for the number of reward points for the double reward point week? Well, this is the time we are finding, so this is 1 week of sales, but we're doubling the amount of points. So we want the mean and the standard deviation of 2R this time. So 2 times 1 week, or 2 times the old mean, that's still 64. The difference is this time the standard deviation is going to be 2 times 8, which is 16. So this time we want letter A. So hopefully that clears up anything you were trying to clear up. If you still have questions, please feel free to email me or come find me. Good luck as you get ready for our first part of our Chapter 6 test.